Okay, so let's solve this question. We have two blocks in contact with each other. This is a 6 kilogram block, this is a 4 kilogram block, and they're on a frictionless surface. And the 6 kilogram block is being pushed by a force of 20 newtons. So you have to find the magnitude of the force that the 6 kilogram block exerts on the 4 kilogram block. Okay, so so now these type of problems you have to consider the blocks individually. Okay, and by that I mean you have to draw the free body diagram and write Newton's second law for each of the block individually. So on, let's call this block A, this block B. So on block A, so if you draw the free body diagram of block A, there is a force F, which is 20 Newton in this direction. So there is an action-reaction force, which you have to figure out in this question, right? So the block B exerts a force on block A, and block A exerts an equal and opposite force on block B. So that force, let's call that FAB. Okay. Now, of course, there's the normal force and A, and then WA. But of course, they're equal, and so flat surface, so they're just going to be equal. They don't appear in Newton's second law in the horizontal direction. Okay. So for block B, the free body diagram is now on block B. So one of the confusions the students have, okay, this force is also acting on this. No, this force is just acting on the 6 kilogram block. It's not acting on this. So when you draw the free body diagram of the 4 kilogram block, you will just show the force that block A exerts on block B. So that's the only horizontal force acting on this. Okay. So that's going to be FBA. Okay. So this is the only force that is acting on block B. And then there's the normal force B and WB. Okay. So so then if you write the equation for this, it's F. I'm just going to do the horizontal direction, the X direction. So F minus F A B equals M A times A, and so make sure you have the mass of block A over here. Okay, and FBA equals MB times A. Okay. Now, according to Newton's third law, FAB, the magnitude of FAB is equal to the magnitude of FBA. Okay. So, so you can just add these two equations together. Okay. If you want, you can call this some F prime if you want. So if you add these two together, you get F equals MA plus MB times A. So acceleration is F over MA plus MB. So that will give you the acceleration of the system, and then in order to get the action-reaction force, in this case, you can just use this equation over here. So you can just plug in this acceleration in this equation. FBA equals MB times A. Okay, so so once you plug in the numbers, the answer turns out to be 8 newtons. Okay, so answer for this is 8 newtons. You can write that over here. Okay, and acceleration, let's plug in the numbers for acceleration also. So that's going to be 20. So F is 20, and MA plus MB, the masses of the two, 6 plus 4 is 10. So you get 10 kilograms. So you get 2 meters per second squared. Okay, and since MB is 4 kilograms, so 4 times 2 is 8. So that gives us our answer. Okay, so that was the first question. We will solve more questions in coming videos. So see you guys.